All right, let's get through this. Test tomorrow. Yep, test tomorrow. I told you about it last week, so don't say what. Huh? I said we could move it to Wednesday if we need to. Huh? I could. I don't think we need to. Let's go through what's going to be on your test. Anybody remember your exponent rules? X to the A times x to the B. What do you do when you see A? Add the exponents. Anybody remember another rule? Anything to the 0 power is equal to 1. What do you do with negative exponents? Flip them and then make the exponent positive, right? What do you do with powers raised to powers? You multiply. What would you do if you have multiple things under an exponent, like x times y raised to the a? They both get raised to the power. And then likewise, if you are dividing, what has to happen? Again, they both get the power, x to the a over y to the a. I feel like I'm forgetting one. Is that all of them? I feel like I'm forgetting one. All right, let's do this. Take a look at page 510. 510. And let's do some of these random questions. Just see. Number 7, 3.6 to the 0 power. What's the answer? 4. What did you say? Did you say 4? 1. How about number 8, where it's negative 1 to the negative 4th power? Do these two negatives cancel? No. Negative exponents never cancel negative numbers. What do you do with negative exponents? Flip them. So this becomes 1 over the negative 1 to the positive 4th power. Now, how many negative signs do I actually have here? 4 of them, which means a negative times a negative times a negative times a negative would be a positive, even number. So the answer is 1. How about a question like number 16? So you have negative 1/2 times x to the negative 2 times y to the negative 4. The negative 1/2, do you do anything with the negative 1/2? Huh? Do you flip negative numbers? No. Negative 1/2 is just negative 1/2. What about the x's? Think of them like this. What do you do with negative exponents? So where should the x's go? To the bottom with the 2, and it should be positive 2. How about the y's? They should go on the bottom. So there's your answer. Really is that easy. So far, so good? Okay. How about a question like number 19 that says q to the negative 1, r to the negative 2, over s to the negative 3. What should we do with that? Where should the q's be? Bottom. and it becomes positive 1, so you don't have to write the exponent. How about the r's? Bottom, and they become positive 2. And the s's? To the top, and they become positive 3. So there's your answer. If you see negative exponents, you move them. Easy stuff? So there will be some of those. There's also going to be scientific notation and power of 10 thing. If I give you, or if you see on a test, 10 to the 7th power, how many zeros is that going to have? It's going to have 7 zeros. 1, 2, 3, 4, 5, 6, 7. What if it was negative 7? Which way do you, so now it's what? So you go left, so now it's going to be a decimal. So how many zeros are you going to have now? Remember, if it's negative, it's 1 less. So it should be 0.1, 2, 3, 4, 6. Now, you could think it's got to have 7 too if you want, but then you got to count the 1 in front of it as well. So you could think there should be 7 zeros either way, but make sure you put the 0 in front of the decimal as well. Easy stuff? How would you write that in scientific notation? Where would you want the decimal? In between the 8 and the 2? Okay. Times 10. And then 3, 6, 9. Yes? How would I do that in scientific notation? Where would you want the decimal? In between the 2 and the 1. And then you got to move it 4, 5, 6, negative 7. Cam, please put that away. Don't care. Okay. If I give you this problem on the test, how do you multiply numbers in scientific notation? What do you do with the 4.18 and the 2? Times them. So that'd be 8.36 times 10. What do you do with the exponents when we multiply? You add them. And you're done. What would you do if instead of multiplying, if I said divide those two numbers? What would you do with the 4.18 and the 2? Divide. So that'd be 2.09. And then what do you do with the exponents? You just subtract. So 30 minus 18 would be 12. Easy enough? Now, keep in mind, if I give you a problem like this, multiply those. What's 8.1 times 2? 16.2. And then what would I do with the exponents? Add them. So what is wrong with that answer? The decimal's in the wrong spot, right? If the answer ends up where the decimal's in the wrong spot, you may have to move it. So where should the decimal be? Between the 1 and the 6. So 1.62. Now, we want these two numbers to be the same. Did this number get bigger or smaller? If this number gets smaller, what has to happen to this number? It has to get bigger, so this should be 24. This is what the answer would be. So when you do the multiplication or the division, if you end up with an answer where the decimal's not in the right spot, you may be forced to move it to get it into the right spot. And then just remember, if this number gets smaller, that one has to get bigger. And likewise, if this one has to get bigger, because maybe it's a 0.16, then this one would have to get smaller. Make sense? So far? Okay. I feel like you guys have all those things. How do you find the degree of a polynomial? How do you find the degree of How do you find the degree of that polynomial? Add all the exponents. So 9 plus 2 is 11 plus 3 is... So first of all, do we care about all of these exponents? Which one do we not care about? We don't care about the one that's attached to the 4. We only care about the 9 and the 2. So the degree of this monomial is what? 11. What's the degree of this monomial? 12. Do we add those numbers together? No, you find the biggest. So 12 would be the degree of that polynomial. Yes? Okay. What if I said put that in standard form, what should come first? The negative 5x to the third should come first. Then the 4x squared. Then the x. And then the 8. If I asked you to name that as well, what kind of polynomial is this? What's the degree? It's 3. What's anything to the third? The degree of poly 3 is? So it's a cubic polynomial. If I took the 8 away, would that change the name? Now it'd be a what? Cubic trinomial. If I took the 5x to the third away, and it's just this. Now it's a trinomial, but it'd be a quadratic trinomial. So we got to know all those. What would that be? What kind of binomial? A linear binomial. Remember, the degree of 0 is a constant. So if you just see this, that would be a constant. I guess you could also call it a constant monomial, but it's just a constant. Degree of 1 is linear. Degree 2 is quadratic. Degree 3 is cubic, right? Those are the big ones. How about problem like this. How do you add those? Combine like terms. What would you put first? 4x squared. Because you got a negative 4x squared and a positive 8x squared. Add them together. And then 3x plus negative 3x goes away, right? And then the negative 2 plus the 5 plus 3. And if I said name that, it'd be a quadratic binomial. How would this problem change if I instead made this a minus? You'd want to change it back to a positive, but what would you have to do? Make all the signs back here change. So you'd want to change to a positive, that'd be a negative, that'd be a positive, that'd be a negative. Now you've got negative 12x squareds. You'd have 6x's and a negative 7. Yes? What do we do if you have 2x minus 3 times, let's say, x plus 7? FOIL. So 2x times x, 2x squared. 2x times 7, 14x. Negative 3 times x, negative 3x. Negative 3 times 7, negative 21. Am I done? No, because now I can combine like terms. I'd still have the 2x squared, but I'd have 11x's. Probably one of the ones I've seen you guys struggle the most with. Are these. What's the only thing I have to do here? Distribute. How do you multiply this 3xy to the fourth times that first term? Multiply. 3 times 7 is 21. How many x's would I have? 3. And how many y's would I have? 8. And then you got to do this first term again, or that term, by the second term. So the 3 and the 5 makes negative 15. How many x's would I have? 5. And how many y's would I have? 6. Easy enough? What is the shortcut to doing a perfect trinomial? How do you find the first term? You take the first term and square it, which you would get 4x squared. How do you find the middle term? You take the 2x and times it by the negative 4. So you times those two together. And then what? Times that by 2. So that'd be negative 8x times 2, negative 16x. And then how do you find the last term? You take the last term, the negative 4, and square that, or positive 16. Easy? Okay. How about, what if it said 2x plus 4 times 2x minus 4? What's the only thing that's different? What happens to those middle terms? They're going to cancel out. So all you got to worry about is 2x times 2x is 4x squared. You got the 4 and the 4 makes 16, and it'll always be minus, right? And the middle term will always cancel out. That's pretty much the whole chapter, guys. So basically, here's what I want you guys looking at. Everybody look at page 510. That first section, use your properties. Is there anything in there that looks like it would cause you problems? Look at the next page, 511. You got your scientific notation, powers of 10. Putting things into scientific notation, taking them out. And then we multiply using our exponents. Where you got to know, do you add the exponents? Do you multiply the exponents? Multiplying numbers in scientific notation. Easy so far? Turn the page. There's going to be ones where you divide using your exponent properties and dividing with scientific notation. Then we talked about the degrees. Find the degree of the polynomial. Put things in standard form. Naming the polynomials. Knowing the cubics and the quadratics and the linear or monomial, binomial, trinomial. And then 7.6 was combining like terms, or subtracting. 7.7 was multiplying and foiling, distributing. And then the last one was the special products, where the shortcuts. Basically, on those 3 pages, out of those 116 problems, anything is fair game for the test. Is there anything out of those 116 problems you would like